We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
1, 0, all engine running. Liftoff. We have a liftoff.
Houston, Tranquility Base here. The Eagle has landed.
Hello. How you doing? Welcome, scientist. This is Orbit at a Tilt, your fun and easy to understand look at space and science and the universe around us. Today we're going to talk about Mars. I'm Adam Tilted, your host, and let's get going. Give me just a second. I've got I'm going to give a shout out to Ecamm Live. I am using a beta version of their software. So there are some changes every time I do this, and that's why I'm a little off at the start here, because we just had an update, which is going to provide some cool features. So let's get started. All right. First thing, I want to thank my sponsors from Patreon, because you were responsible for this beauty that I'm using right here, this microphone. And by the way, if you could give me some feedback on how the sound is on this, I'm going to give a little listen myself. Yeah, so my Patreon patrons, they made this possible, so thank you. I also got these headphones, so thank you for that. If you'd like to become a monthly sponsor, you can do that at patreon.com. Or if you would just like to give a one-time donation, there is a tip jar link in the description, paypal.me/AdamTilted. All right, so Mars. Let's switch over to our solar system model. And hold on, let's go back to here. All right, so we've got Mars. Mars is the fourth planet from the sun. It is the outermost rocky planet. Past Mars in the solar system, all the planets are either gas giants or ice giants, which ice giants and gas giants are very similar. So those, that's Saturn. There's Jupiter, Saturn, Uranus, Neptune. Pluto is a rock, but it is not a planet. So we'll talk about that again if you want. All right, so Mars, if you look right here, this is, let me put this back to the actual time. And in fact, let's move time back just a little bit, a couple months, so we can see this progression in our orbit. So Earth is down here. Can you see that? Yeah. Okay. Earth is down here. Mars is over here. We'll move this up a little bit so we can start to see. All right. So you can see that as we're getting closer, this is April, May, you can see they're getting closer and closer to each other. Both Earth and Mars have an elliptical orbit, so when they are both on this short end, the close end of the egg shape, then they get really close to each other. So right around here is where we are right now. So this is July 23rd. On Friday, wait, where are my notes? Okay, on Friday, sorry. On Friday, I wrote my notes in a color pen that I can barely read. I won't do that again. On Friday, Mars will be at opposition, and that means, let's see if I can move this to Friday. That means that Earth and will be right in between Mars and the sun. This is generally the best time to look at a planet through a telescope. Unfortunately, right now, even though Mars is closer to us than it's been in a really, really long time, it's also engulfed in a global dust storm right now. So that's a bit of a bummer, because normally, as close as it is right now, it'll reach its closest approach on next Tuesday. So let's move that ahead and we'll see closer. That's the closest approach to the Earth. And we can see this in the sky. Mars looks much bigger and brighter than it does normally. It doesn't get very high above the horizon until the middle of the night, though. So if you don't have a good view, you won't be able to see it unless you stay up late. But it is worth taking a look because it does look pretty magnificent. And if it weren't for the dust storm, we would be able to make out some of the features on Mars, because it's so much closer to us. But take a look at it anyway. You'll see it. I'm going to show you what that looks like. Let's go ahead and I'm going to skip ahead to some of the Skywatch stuff because it's pertinent to what we're doing right now. Okay, this is tonight, and you can see Mars right there on the horizon, big and bright. And this is at 2100. What is that? 9 o'clock? Yeah, 9 o'clock. Just after dark. You'll see it's very low on the horizon. We also, after dark, if you have a really dark sky and a good view of the western horizon, you may be able to catch Mercury, which means that every naked eye planet will be visible in the sky, which is pretty cool. That's happening right now. So Mercury is there, Venus, big and bright again, and let me zoom out a bit. We see Jupiter high in the sky already after sunset. Take a look at Jupiter with binoculars, at least. You can see the moons, and it's really cool. And then we've got the moon. Speaking of the moon, we've got the moon and Saturn, which are going to be 2 degrees apart. Remember, that's about the width of your index finger at arm's length. So your finger would cover the moon and Saturn. That's how close they'll be in the sky. So that'll be pretty. That will not be a good time to look at Saturn through a telescope because the light from the moon will be washing it out. Then we've got Mars down here, and I'm going to move time ahead a little bit and zoom back out. And you'll see that along the same line, Uranus is going to come up towards the middle of the night. This is about 1 o'clock in the morning now. There it is, Uranus. You can see Uranus with binoculars or a telescope. And Neptune is even up here somewhere. Can't remember where. But if you have a good telescope, you may be able to see Neptune as well. By the way, this application I'm using is called Stellarium. I highly recommend it. It's fun for seeing what's up in the sky. You can run time forwards, backwards, speed it up, slow it down. It's pretty cool. Okay, so back to Mars. A few other things about Mars. Let's zoom into Mars and take a look. Mars is about half the size of Earth, a little bit more maybe. It has a third of the gravity. And Mars has as much land area as the Earth does. It just doesn't have the oceans. But there is water on Mars. In fact, there's a lot of water on Mars. There's much more water than we ever thought. Mars is by far the most intensely studied planet beyond Earth in our solar system. We have sent countless missions to Mars, orbiters, probes, robots. Right now, there is a fleet at Mars, and I'm just going to read off what some of these are, because it's pretty crazy. So we've got Mars Odyssey is in orbit. It's been there since 2001, and it is studying the geology, the climate, mineralogy on Mars. Mars Express launched in 2003, and it was searching for traces of water from orbit. Also in 2003, the twin rovers Spirit and Opportunity launched, and remarkably, even though they were only supposed to go for about a month, the Opportunity rover is just still going strong, which is crazy, because that's like 15 years ago. So they got a good use out of their money for that. Spirit got stuck in a sand pit and was not able to position itself. Both of those rovers are powered by solar panels, and so during the winter it wasn't able to charge its batteries because it couldn't move to a proper position, and so unfortunately Spirit died after doing some great science. But its twin Opportunity is still going, although now with this global dust storm we're worried because those solar panels get covered in dust, and then they're not very efficient at collecting the power that the rover needs just to keep the components warm because it gets very cold on Mars. All right, next we've got the Mars Reconnaissance Orbiter, which is now in its 4th mission extension. It was launched in 2005, and this orbiter was designed originally to scope out, where rovers would land. Now that it's on its 4th mission extension, it's been there for a long time, and it's been investigating seasonal changes and global weather phenomena like this dust storm, for instance. So that's been pretty amazing. And by the way, if you don't mind, if you're in the audience right now, just give me a thumbs up or some kind of comment, because Facebook has changed the way that they're allowing comments, and I just want to make sure that I'm seeing your comments if you're making them, because I don't know if that's happening or not. All right. So Mars Reconnaissance Orbiter, of course, we've got the Curiosity rover, which is on Mars. That is the largest robot laboratory we have ever sent anywhere. It landed on another world. That was launched in 2011, and it has already accomplished its scientific mission by proving that life could have existed in the past. That the climate on Mars makes it did leave traces that it could have been habitable in the past. Thanks, Mom, for the comment. Appreciate that. It is coming through. Couple of Mars missions you may not know about. I'm just going to run through these real quick because I want to show you the SpaceX launch as well. India has an orbiter called the Mars Orbiter Mission, or MOM. Isn't that cute? There is another orbiter called MAVEN, which stands for the Mars Atmospheric and Volatile Evolution, and that is looking at how the atmosphere of Mars is evaporating into space, because that's what is happening, which is why there's no liquid water on the surface of Mars, even though there is a bunch of water there in the form of ice in the polar caps and under the surface. There's not enough pressure on the surface for water to stay in a liquid form. It just sublimates into gas, and Mars does not have enough gravity to maintain a thick atmosphere, so it just slowly evaporates into space. The European Space Agency has an orbiter around Mars called the ExoMars Trace Gas Orbiter, and it is looking for evidence of methane and other gases that may be signatures of biological processes. And then launching this year, or actually they have launched, they're on their way to Mars, but they haven't gotten there yet, are two kind of mini missions. One is called InSight, and it's a lander. It's not a rover, it's a lander, and it is going to drill into the Martian surface and measure tectonic activity, because we don't know much about the dynamics of the Martian surface. So that's what InSight will do. And then the other mission that's on its way is a set of CubeSats. And those are small satellites that are just in a cube, and this is a kind of the new trend in research, because they're a lot cheaper to manufacture and deploy. So I think there are 5 of these that are going. The mission is named Mars Cube 1, or Marco, and it's kind of a proof of concept mission, just to show that small satellites have the ability to do some deep space exploration and provide real-time support. For instance, next time we land a big rover on Mars, we may send these CubeSats to help relay information. So and there are lots of other plans for Mars. Obviously, Mars seems like it might be a good second home for humans. I have different ideas about that, but we'll talk about that at another time. All right. If you have any questions about Mars, drop them in the comments. There's a lot I could tell you about Mars, and I think I'll save the rest of it for another time, because I want to get onto this launch. This launch is pretty cool. Now, I've shown you, in the last couple weeks, I've shown you 2 launches and a release and they were all related to resupplying the International Space Station. This launch is different. This launch is a launch by SpaceX to put a telecommunications satellite in orbit. And you may notice some differences if you're paying really close attention to the way the launch goes when we want to send something into a geosynchronous orbit, which means it orbits the same place above the Earth, as opposed to rendezvousing with the space station. All right. And the video that I'm going to show you is courtesy of SpaceX. You can find it on their website. Nope, that's not right. You can find it on their website. What happened to my... Hold on, it went away. Here we go. Hi, Danica. Just in time for the SpaceX launch. Okay, let me try this again. Okay. There we go. All right. Okay, so SpaceX. Well, let's get through all their promo stuff. All right, this is Launch Complex 40 at Cape Canaveral, Florida, Earth. This is the Falcon 9 rocket with the Telstar 19 satellite on top. So here you can see this is called the fairing. Yay, I like it too, Danica. The launches are the best. All right, so we got the fairing is very important during the launch process because it provides protection for the satellite and creates an aerodynamic point for the rocket to go in. Now, I want to tell you something important to understand. I was going to do a how to get into orbit show before I started showing these launches, but whatever. You guys will catch on. But to get into orbit around the Earth, you don't just have to go up. You have to go up and sideways, okay? Because the basic idea is that you're going to go up and sideways so that when you fall back down, you miss the Earth. So if you have enough sideways momentum and you get high enough, you actually fall and you just keep missing the Earth. That's the plan. So when we are launching here, you'll see that's why it's in different stages, because one stage is going to get us up, the other stage is going to get us sideways, and then we get into orbit around the Earth and use that momentum to help either rendezvous with the space station or put a satellite in orbit. All right, so let me see, where did I mark my first timestamp? Because this whole thing is quite long, but we don't want to watch the whole thing. Okay, we're going to skip ahead to... All right, this shot. They're using a brand new design here. It's the first time they've launched it from this location, but they have done a previous launch test before. The main thing you'll notice is this black piece in the middle. Now, this is called a Block 5 design, and it allows them to use the Falcon 9 rocket up to 10 times and decreases the amount of time it decreases the amount of time it takes to refurbish the rocket. So that's exciting that they've made this advancement in rocket technology, because remember, SpaceX is all about bringing down the cost of space travel. So as much as we can reuse these rockets that cost millions of dollars, the better. Okay, so right now what's happening is what's called loading. And I'm going to actually kind of speed this up like 5 times. Thank you, Danica. All right, so you can see this venting. They're loading it with the propellants, which includes rocket grade kerosene, and then it's pressured with liquid hydrogen and helium. And so you're seeing this venting because the liquid hydrogen has to be cooled way down to make it a liquid, and they put it in here. But then that outer surface, it's warm in Florida, so it turns back into a gas. So that's what you're seeing there, with all that stuff leaking out of the side. All right, I'll keep this running, and I'll give you a little bit of information about what we're looking at. Now, in space, normally when you want to ignite something, you add oxygen. I know, kerosene, right? You add oxygen to a flammable substance, and that's what causes the combustion. But in space, there is no oxygen. I want to show you this. Sorry. I'll come back to that in a minute. Okay, so whoa, I don't know what happened. Let me know if you guys are still there. I just had something weird happen. Weird alarms going off in my brain. That wouldn't be unlikely either. All right. Okay, so in order to accomplish ignition in the vacuum of space, I know, right? One day I'm going to be broadcasting for SpaceX. Welcome, as we cover the first human landing on Mars, right? or we go back to the moon, even better. Okay, so there's no oxygen in space, so you can't just light a match and let it burn. So they use a chemical reaction. And this chemical reaction, it gives off a green glow. So when we watch this launch, after we get into space, what's going to happen is the first stage is gonna separate, and it's gonna land. Boom. All right. When that happens, you're gonna see the second ignition, the second engine start up. If you look carefully, you'll see a green glow because that chemical reaction causes a green color to emit. Now this, I'm going to show you this satellite, and it is going to bring internet access to everyone. Pretty much is the goal. Okay, I'm turning on the audio. I'm hoping you can hear this. Great. Okay. So that satellite, as I mentioned, is going to be deployed to provide broadband internet access and telecommunications to remote areas. That is really exciting. So this is I want to say the 13th or 18th launch for SpaceX this year. I wrote that down somewhere, but I just can't remember. I can't see it either. All right. So I'm going to zip us ahead to the final T-minus 5 minutes. And then we're just going to let this go. I want you to hear the back and forth between the tower, the control, and the also the companies that are in charge of the satellite are in on this too. So let's switch back over there. Make sure I got this on.
At T-minus 1 minute, the rocket's internal flight computers will take full control, which you'll hear on the countdown net as Falcon 9 is in startup. So, with all systems go, let's listen into the final 5 minutes of countdown now.
You can hear that venting still, and that's gonna keep going up until startup. This is 1:30 in the morning 2 days ago, I believe, and it was pretty windy. They were a little concerned about that. The wind was at 30 miles an hour. which is their limit. Oh, you can't see the countdown. Hold on. There we go. Okay, skipping ahead. T-minus 2 minutes.
Stage 2 locks is close out for flight.
So now the filling procedure is completing. So you notice it said stage 2 lock closed up for flight. So it's full, it's done.
Gas looks close out.
Okay, I believe that was the secondary engine, which is what the payload is attached to.
AFTS is on for flight. Vehicles in startup.
Okay.
Is complete.
So everything's being taken over by the computers by now at this point. All lights are green, ready to go.
Go for launch.
Are you excited? I'm gonna move myself out of the way down here so you can see.
Stage 1 tanks present for
Here's
flight.
the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition.
Ignition. Liftoff.
Liftoff.
Vehicle pushing down range.
Okay. Now, you can see, now if this is working properly, you just hear me now and not the video. All right, so let me know if that's not what's happening. But you can see those 9 Merlin engines on the bottom there, all firing. It's beautiful. This is the onboard camera looking back. The next event that's coming up is this Max Q. Max Q is when the vehicle is reaching the most atmospheric pressure. So once you pass Max Q, which I think we have just done at this point, then it's a lot easier on the vehicle past that point. Now, coming up next, we're going to have 3 events happen right in a row, okay? And that is going to be the main engine cutoff. So these 9 rockets there will cut off. Then we'll have stage separation while there are no rockets burning. And the first stage will come back to land on the drone ship, Of Course I Still Love You, which is in the Atlantic Ocean. And then we will have the second engine startup. So main engine cutoff, which is called MECO, and then stage separation and second engine start, SES, number 1. All right, so let's watch this as it goes. I'm gonna move this a little closer, a little closer, a little closer. All right, here we go. Main engine cutoff, stage separation, secondary engine startup. You see that green? Here, let me go back. I'll go back. You see that flash of green right there? That's what I was talking about, that chemical. All right, next event is going to be the entry burn for the first stage. If you remember, we watched SpaceX launch a Dragon capsule to the International Space Station. And at this point in that launch, the first stage had a burn, an engine burn, to adjust its trajectory. We don't have that here because it's just going to follow a ballistic course over the ocean. And then once it gets over the ocean, they'll do an entry burn to position it to land on the ship. All right, so you might have noticed that difference. The second engine, this burn is for it's bringing it higher and higher into a higher orbit. We're still going kind of up and sideways, and in a moment, let me see if I speed this up a little bit. Okay. All right, so we're about to get an entry burn. Oh, I forgot. All right, these things all happen at the same time. You see this down here? This cluster of activities. So we're going to get the entry burn, and then we're going to have bam, bam, bam. These things are all basically happening at the same time, but in different places. So we've got this first stage over here on the left, which is coming back to land on a drone ship in the ocean. Boom. And on the right, we see the second stage rocket. There's the entry burn. Meanwhile, second stage is still blasting its way into space. So this burn here goes for, I think, 40 seconds. And it takes the first stage from way more than the speed of a commercial airline to 0 in the course of 90 seconds. So that's quite a burn. I mean, this thing is hauling butt when it is basically falling back down towards the Earth. So to be able to stop it and basically let it hover down to land on the drone ship amazes me every time I see it. We still got the secondary engine burn going for the payload. Now you're going to notice like a lot of these SpaceX, I'm going to speed this up a little bit. A lot of these SpaceX feeds, they lose connection with the drone ship, which is expected because you've got a rocket landing. Okay, that's bound to cause some interference. So that feed will cut in and out, but we will get to see it landed. All right, we're coming up on all the fun stuff. All right, there's the landing ship. Of course, I still love you, waiting in the Atlantic Ocean. We're going to lose the connection here in a minute, but you can see there's the landing legs deployed, and it's almost down and then cuts out. So here we can see this is the trajectory that it is currently on. This is not the trajectory that it needs to be on. So the secondary engine cutoff happened. Secondary engine cutoff number 1. And then we're going to have, you can see here at the bottom, we're going to coast here for a while. It's going to do an orbit coast. It's gathering some orbital momentum. And then it's going to do a second engine startup to adjust its trajectory to what it needs. So we're going to put this in fast forward. There's the first stage landed on the ship. And I want you to notice, you see all that stuff flying around? That doesn't mean this is fake. It means that there's ice and stuff. Space, especially at this altitude, is not empty. There's a lot of crap up there, so don't let that throw you off. All right, I'm going to speed this up a lot so we can see this movement across the ocean towards Africa. When it gets over the continent of Africa is when we're about to have that second engine startup. I'll slow us down to real time for that. And when that happens, I want you to watch this other trajectory line. Almost there. Let's see if I can turn this up for you.
Welcome back, everybody, as we near the end of our brief coast period where Stage 2 is about to reignite to perform its second of the 2 planned burns. Now we're about 40 seconds away from SES-2, which is second engine start number 2. Again, that's the second burn, and it will last for about 40 seconds, at which point you'll hear the terminating SECO-2 callout, which stands for second engine cutoff number 2. So stand by about 20 seconds until SES-2.
Please stand by. Thanks for hanging in there with this. Is a longer show today. I probably should have done this in 2 episodes, but I didn't. All right, almost there. Now, again, I want you to watch the trajectory lines that are projected. There's the second engine startup number 2. So you see how that's adjusting the trajectory?
During that brief slice, we did see MVAC ignite. Again, 40-second burn here to perform final adjustments to get Telstar pointed into its desired final trajectory.
Excellent. Okay, so that burns for 40 seconds, and then secondary engine cutoff, and we're about to deploy. The deployment is done with a spring system. So the satellite is attached to the second stage with a spring-loaded release mechanism. So it'll have this gentle push to send it off into orbit. Coming up, coming up. I'm impatient. Okay, here we go. Here we go. Look at that. Cool, huh? All right, so that's a launch of a satellite into geostationary transfer orbit. Fun. Okay, and now they have a couple other launches planned. I try to grab these videos whenever they're available. I think it's really interesting to see how they do these launches because they don't do them all the same way all the time. They're constantly trying new things, and to make it cheaper, faster, safer. So I'm going to keep showing you these as whenever I can get the videos available. And if there is a launch from the past that you're interested in seeing, let me know. NASA has a pretty good archive of any of their launches, so if you're interested in looking at some of the Apollo launches or space shuttle launches, or there's one in particular that you're really interested in, let me know. Maybe not the Challenger one because that makes me cry, but yeah. So I do have some Skywatching tips, but we've been talking, and I'm way over time. So I am just going to remind you tonight to look at Saturn and the Moon, all right? And keep an eye on Mars. Take a look out for Mars between now and when I talk to you next week, because it will be high in the, it will be bright and close, and it will be high in the middle of the night. So if you're a night owl, it's a good time to see it. All right, thanks for tuning in, and thanks for your support. I really appreciate it. And until I see you next week, don't forget to look up. Bye.
We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
1, 0, all engine running. Liftoff. We have a liftoff.
Houston, Tranquility Base here. The Eagle has landed.